Okay, so this is for row work, these 6 problems. If you've started number 1 or if you need help getting started with the number 1, I'll go ahead and get that started. So plus 4 means to the left 4, and then minus 5 is down 5. Looking at this, we're going to have an absolute value function, so the graph will look something like this. So for the first point, we have to go to the left 4, down 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, and plot that point. Then the next step, we look at whether the stretch or the slope, as we sometimes call it, for absolute value, it's nothing there, so it's just 1. So we go up 1 over 1 for these points, like this. Of course, there's some human error in there, but it look like this. And then in the other direction, again, up 1 over 1 until you get this. Okay, and then filling in the domain and range. Domain would be negative infinity to infinity. That's the x values, and we can see that it goes forever and ever to the left and forever and ever to the right. Then for range, our y values, our lowest y value here would be negative 5. So we put in bracket, negative 5, and then it goes up and up forever and ever, so to infinity and beyond. And then you'll repeat that for these 3. And then down here, you'll have quadratics, which you'll need to set up a function table for, so that way you have values to graph. But I'll go over that in a second if you get stuck. Okay, so complete these problems. I'm going to pause this. Okay, so a lot of you have done these 2. I'll go back and fill in the answers in a second so you can check it. But for those of you who are starting the quadratics down at the bottom, we know it's a quadratic because it has that square right there. So with a quadratic, the graph is going to look more like this. Oh, wait, you couldn't see what I drew. More like this. So that's what we can expect. As far as the transformation, we look for about the same things. Minus 2 would mean to the right 2. And then plus 5 would mean up 5 for the initial point. So to the right 2, up 5, 1, 2, 3, 4, 5. So there's our initial point. And now we need points to plot to make this shape. Yes.
Can you go over 15?
Maybe. I want to give everybody time to catch up. Okay. So this one right here. To get the points now, we're going to use this function table, plug in numbers into this to get additional points. The numbers I'm going to choose are close to this. So here, this is at 2. I might choose 3 and 4 for my x values.
And how do you decide what to put on the x?
I chose numbers that, so this is at x equals 2. So I chose 3 and 4 because I need it to fit on the graph.
Gotcha.
Yep. And then, so from here, I'm going to plug that into this. 1 squared would be 1, plus 5 is 6. And then if I plug in 4, get 4 plus 5, which is 9. And then these are the points that I'm going to plot. Wait, what happened? Oh, wait. 3, 1, 2, 3, 4, 5, 6.
3 minus 2 is 1.
1 squared would be 1, plus 5 is 6.
Okay.
And 4, 9. So there's my graph. Now I need to identify my domain. This would continue going out to the left, and this would continue going out over so slightly to the right. So my domain is negative infinity to infinity. And then range, my y values, my lowest y value is going to be here at y equals 5. So my lowest one, I'm going to put a bracket for 5. And then it goes up forever, so it go to infinity and beyond. And I'm done. Okay. So continue trying to do it by yourself. Even if you're semi-guessing, I'm going to play my recording. Okay, so just check your answers, and then we're going to move over to the other page. Okay, so we're moving over to the page before it. I started with transformations because I feel like that's what you're most comfortable with at this point. So move over to this page that says Graphing Review Worksheet. It is page 18, but there's no page number at the bottom. Let's see. Graphing Review Worksheet. I wrote a 18, but for whatever reason, the page number is probably covered by a graph here. Graphing Review Worksheet.
You said 18?
Yeah, but it's not numbered for some reason. Okay, we're here on Graphing Review Worksheet. We are going to get into piecewise functions, but honestly, before we get into this, we're going to go over the step functions. As far as step functions, tested on this, it's literally choosing out of a multiple choice answer choices. So I just want you to get the gist of step functions. My graphs are really small to even be like graphing these on. But remember, a step function, this symbol here, it means whatever value is 1 less than that. So if I have a value of 5.5, the integer less than that is going to be 5, and it would equal 5. So because of that, these are graphed kind of weird. But one thing that is consistent to the other transformations we've been doing is if this is +1, that means to the left 1. So our original point is going to be to the left 1 of the origin. So left 1, and then here's what this is going to look like. To the left of 0, I'm putting a little tiny closed dot, and then it goes to an open dot right here, which is hard to see. But closed dot, open dot, and it makes these little steps, hence step function. Like this. And the slope is just 1. There's no coefficient out there. And that's what it looks like. And so try to graph it as best you can on your paper. I realize it's not going to be perfect, especially if you're dealing with the small version like I have.
Shouldn't the closed dot be on 0, 0?
No, because of this transformation. It's the left one. Yeah. And then again, just try to graph it as best you can. I know your paper's just as small as mine, a lot of you. Number 8, -3, that means to the right 3. So we're going to start ours, go to the right 3, put your closed dot, and same idea. It's very hard to graph on this little tiny piece of paper. Because, I don't know, step function. It's, so the closed dot includes the number before it. So in this case, it includes 3. And then anything larger, so like 3.3 is actually 3, or 3.8 is, the answer is actually 3. Yeah, it's okay. We just go with it. I just teach the curriculum, I don't create it, so. Yeah, but it'll look like this. And of course it would continue, but. And the next one, inside the brackets just x, and then it's +1 out. So this would be up 1. So from 0, we're going to go up 1. So closed dot would be at 1 on the y. And same idea. Yours might be clearer or worse than mine. Again, I'm not nitpicking, just put something on there. Okay, thank you. Next. Okay, now we're going up to piecewise. You got something down? Does it look better or worse than mine? Worse.
I got the full size.
Oh, you got the full size? You got
So I
the...
actually had a lot of room.
Oh, nice. Okay. Now, moving up to the top, we're doing piecewise. Some of you might find this like, you got it now. Some of you might still need like step-by-step instructions. Wherever you're at, I'm using... Yes, if you'd like to use If you feel like you've graduated from the colored pencils, that's up to you. Yes. Yes, you may. Sign out. Okay, piecewise.
How many colors do we need?
3 max. I mean, you could use a pencil as a color too if you want. Okay, so starting with number 1, it says x is less than or equal to -2, so I will make that my blue side of the graph. X is less than or equal to -2, I labeled that, and my equation here would be y equals x plus 2. Then the other side is x is greater than -2, so the entire other side is going to be red. And the equation there is y, whoa, what's up with my colored pencil? Y equals 3x. Then from here, I'm going to graph my lines and then erase whatever is not in the right section. So for my first one, y equals x plus 2. Y-intercept is at 2. The slope is 1, so it's going to continue upwards, up 1 over 1. Also in this direction as well. I'm going to lightly graph this line. And then x is less than or equal to -2. So finding -2 here and close dot because it's less than or equal to, and then erasing the rest. Last step.
Is that an open or closed dot?
It is closed because x is less than or equal to -2. So we got a blue arrow.
The slope is 1.
Yes. And then the next one, y equals 3x. There's no y-intercept labeled, so it's just 0 is the y-intercept. Up 3 over 1. And then it would be an open dot at -2. What's up?
Sorry, how do we graph it? So it's
The y-intercept is 0, so that can be your initial point, and then I did up 3 over 1. But I also went down 3 over 1, too, to get it into that section over here.
okay.
Does that make
Okay,
sense?
I got it.
Okay.
I just have a brain fart.
It's okay.
Don't you want it in the red section?
Yeah, it is in the red section. What do you mean?
But I mean, like, you continued it to the other section.
So I continued it to -2. And then domain, x values, it goes forever and ever to the left and forever and ever to the right. It does include this -2 because I do have a closed dot, so -infinity to infinity for domain. Range, it goes down forever and ever and up forever and ever, so -infinity to infinity. Yes, it's just review. If you got this and you feel confident, work ahead of me and then just check back and make sure you're getting the right answers. If you still want step-by-step instructions, you can hang with me for step-by-step. Okay, next one. We'll do top one blue and bottom one red again. X is greater than 0, so that would be everything greater than 0 this way. And the bottom one, x is less than 0. So everything less than 0 this way. Y equals -x plus 4. And y equals -2x minus 2. Okay, now I'm graphing lines. First one, y-intercept at 4. So I got a dot right here. It's actually going to be an open dot because x is greater than 0, not equal to. And then my slope is -1. So I'm going to go over here. Technically be down 1 over 1 over here. But that part, oh wait, I am doing it right. Okay, we're good.
It intercepts at 4, right?
Yes. Then down 1 over 1, so it goes this way.
Why is it an open dot?
Because x is greater than 0, it doesn't include it.
Oh.
Yeah. And this is blue. And then the next line, y-intercepts at -2. So open dot at -2. And then my slope is, yeah. What's that? Why to go up 4?
Oh wait, I went the wrong way. I went
Not to
with the red.
sideways, but then
Wait.
it's not a function, it's a.
We're graphing this. We graph this. So y-intercept is 4. That's why, yeah. And then our slope was -1.
Hold on.
Yes, it's okay. No, that's why, yep, we're good.
I went the wrong way and used the wrong color.
I know, it's backwards in this one because, yeah, the first one's to the right instead of. Okay, so then we have a slope of -2. That's down 2 over 1, but this section isn't included over here. It actually needs to be in that section. So I just continue the line that way.
And then those two ones.
Then this gets erased. Yeah, -2, 1. So your instinct is to go -2, 1, but that's not part of the red section. Okay, and domain. It's going to go forever to the left, forever to the right. Something that happens with this one is we have an open dot on 0, and there actually are no points exactly on 0. So our domain is actually -infinity to 0, parentheses, then 0 to infinity.
Why is that the domain?
What's that? Because our 0 doesn't have any points on it. We have 2 open dots on 0. So everything up until 0 and everything after 0 is included, including 0.0001 and -0.001, but not 0.
That's kind of mean.
Yes, 0 is left out here. And then range.
Was it the same for range as well?
No, actually.
They're on both on the y-intercept.
I'm making your brains think. Yeah, but like, look, there's values all the way up your y. Yeah. Next. Okay, another 2. Let's switch up the colors. Maybe green. Green and red. Merry Christmas. Happy holidays. Okay. Green, x is less than 0, so it'd be this way.
So green is on top, right?
Yeah, I'm doing green on top. And then red, x is greater than 0, so everything this way. Y equals x for green. And y equals 2 for red. And then graphing. No y-intercept for this, so y-intercept is just 0. And the slope is 1. So my instinct is to go up 1 over 1, but that's not included, so I'm going to go this way too.
We're
I know.
doing it right now.
I hope you all took your, maybe I can't do that.
Is it open dot?
Yes, it is an open dot for the green. And then for red, y equals 2, close dot on 0, close dot, y equals 2, like this. Okay. Then domain, negative infinity to infinity and beyond. And range, it's all negative numbers, and then it gets up to 0, and then there's a break in between 0 and 2. So negative infinity up until 0, parentheses because it has an open dot on 0. Then it picks up again at just 2. Close bracket 2.
How's it negative?
Range, the green line goes down.
No.
Anybody working ahead?
Nope.
Racing through this? No?
I'm gonna cry.
You're gonna cry? No, don't cry.
I'm gonna do it.
You can do it.
Try.
You can do it. Okay, next 3. We got 9 minutes. Can we do this in 4 minutes? I don't know. Okay. My last class finished this up. Okay, I'm gonna go quickly. So I got red, green, and blue. See if I can finish this before class is over. X is less than or equal to 0, so my red value is over here. Green is from 0 to 3. And blue is from 3 onward. Okay, and red is going to be y equals negative 2. Green, y equals 2x. And then blue, y equals 8.
How far over is the little green section? Is it 0 to 3?
0 to 3. Okay, now plotting my points. Y equals negative 2. Close dot on 0, and it would go this way. Then for green, I have 2x, so it would be y-intercept of 0 up 2 over 1.
What color is that side there? It's red.
Yeah. And then close dot. Okay, so open dot, close dot. This is green. So this here is my red. This here is my green. And then blue, y equals 8 will be up here. And close dot.
Why did you have an open dot on 0?
Is that from
Because 0 is not equal to x.
0?
There we go.
What's that top number for green? It's 0. It's the origin to.
I went up 3 over 1, up 3 over 1. I don't know, wherever it landed.
It was 3?
Oh, did I
Wasn't it 2?
put it on the wrong spot? Yeah, I did. Maybe. I don't know.
Say, mine's a little more broken.
See, this is what happens when you rush. Don't rush, kids. Okay, up 3 over 1. You're right, I did rush, and I missed something. I think. Yeah. Okay, it is on 2. Thank you, Shreya. But why isn't it... Oh, it's the slopes of 2, not 3. That's what I'm missing. No, I had it right, I think.
Wait, up 3 over 1.
The slope is 2. Up 2 over 1. There we go. We good. Open dot. We got this. We can do this, guys.
Up,
That just turned into like poop green.
up 2 over 1.
Yes. 2x. Domain. Negative infinity. Is that a closed dot? Yeah, it is. Okay. To infinity. And then range would be at negative 2, close bracket. Then from 0 to 1, 2, 3, 4, 5, 6. So 0 to 6, close bracket, and then again at 8. Done. Next one.
We'll have homework on that tonight?
Just yesterday's if you didn't do it.
Oh, sweet.
Yeah. Yeah, you don't have a school. I'll make this green and blue.
Why is the blue line there?
Okay, hold on. Okay, so here's the last. Y'all still have 5 minutes. 5 minutes is a lot of time. I'm finishing this. Don't pack up. Finish it. You good? X is less than -1.
It's -1?
Yeah, then -1 to +1 for green, and then blue is 3 and greater. Eric, keep doing your work. It's packed up. Thank you. Okay. Then we have here y equals -x, so that'll be this way. Open dot. And then green, y equals 0. So from -1 to 1, and it is close dot, close dot. And then for this, a slope of 1. Looks like this. Domain,
Starts 3 up.
-infinity to 1. And then 3 to infinity.
Isn't the red line supposed to be negative, or is that?
Good call. Yes, it is a negative slope, which would mean it would go down this way, but we erased that part of the line. Yeah. I'm challenging your brain.
Why is the red graph at? Like,
The red is -1 over and down. Like x is less, and then green is like right in the middle, which is hard to see. It's from -1 to 1. Y'all. Then x is less than -1. You can do it. X is greater than 1 this way. This is red. This is green. Don't pack up. You'll be okay. Y equals 3. I get open dot, go this way. And then y-intercept of 1 and the slope of 1 goes like this.
will this be on school?
Yes, it will. I'll upload the recording. And then open dot at 1. And up to infinity and beyond. So this would be red. This would be green. Domain is -infinity to -1. And then 1 to infinity. Range would be, where is this? It would be 2 and up. So, parentheses, -2 to infinity and beyond. Done. Okay, now you can pack up. You can get your phones if you'd like.